Hey everyone, Web3 and JavaScript, doesn't that almost sound like a contradiction in itself? Almost like an anachronism? Web3 is so advanced technology, why do we need that really old technology called JavaScript to do Web3? Well, the secret is easy and it's just called ubiquity. We want to use Web3 on the tools we already own, right? We want to use our browsers. You guessed it, the web browsers, the Chromes, the Edges, the Firefoxes, the Safaris that each of you are already using, right? If we need to give you a different tool, it's going to be hard to change people's behavior, right? So we want it to run on everyday browsers, and guess what's ubiquitous in all these browsers? You guessed it, JavaScript. And now some people might say, oh, there are some alternatives to JavaScript, right? We could use, for example, WASM, W-A-S-M, which is an acronym for WebAssembly. It has gained some traction, but it's not a full-blown alternative to JavaScript. There's so many things you can do in JavaScript that WASM isn't built for. So at the end of the day, there is no real alternative. We just need those browsers, and the only thing that all browsers can do is JavaScript. So even for Web3 to become a reality, we need to have it on our browsers, right? And that's something Ethereum and the Ethereum team discovered even back in the day. And they created what was called Web3.js, and it's a library of JavaScript functions that developers can use in their code when they build the front end of a Web3 app. And with the help of these JavaScript libraries, they can access the blockchain. They can, for the original Ethereum Web3.js, you can access Ethereum nodes from an app in your browser. So now, even with Solana, a way faster blockchain, and the guys that know me know that I'm a big Solana fan, right? So even on Solana, they recreated that Web3.js just to access, in that case, the Solana chain, not the Ethereum chain, right? And, you know, it's a long library. It has all the issues that JavaScript as a language has. But, you know, it's doing its job, and it's bridging these two worlds, the world of web browsers that we're all used to with the world of blockchain. So that's how Web3.js came to be, right? And then how does it all evolve? Well, there are some new features in the xweb3.js, and X stands for extended. It's an extended Web3.js. And I'm going to dive into it, what it means. But if you like content like this, please give me that like button. I really appreciate it. It's really important for the YouTube algorithm. Subscribe to my channel and comment down below. Ask me questions. Tell me you think the same. Tell me if it was helpful for you, or tell me if I made a mistake somewhere and just told you something that's not this here, right? But maybe you think it was something that sounded like this. All right, but for now, let's move on. So with the xweb3, we're adding extended functionality there to access something that's called the scalable storage layer, right? So, and the scalable storage layers was missing in smart contract blockchains. That's why today's Web3 apps look so limited, right? They are nothing like Web2 apps that we all know that are out there in the internet. They are very limited, and that's because they cannot access a scalable storage layer. So that's what we're building at Xandeum, Xandeum.com. Link is in the description. Please learn about Xandeum. So with the xweb3, we can send X transactions. So that would be extended transactions. You can also call it Xandeum transactions, but I like to call it the extended Web3.js and the extended transactions. And these transactions can access the scalable storage layer, right? So that is the brave new world that makes, you know, all of Web2 technology suddenly be transferable to Web3, make it decentralized, and make Web3 a real reality. So then we send an X transaction, and all these in the Web3.js, all transactions are being encoded into a message because the message is going to be sent over the wire, right? So that's what it's all about. We send a message from the browser over the internet through a wire somehow to the blockchain. And on the blockchain, it's going to be processed, right? And what we're doing here at Xandeum to create our xweb3.js, we are adding something to the message format, to the really, really low-level message format that defines the underlying blockchain. And in our case, that's the Solana chain because we're building on the Solana code base. But what we're doing is we're looking into that message format, like, 10 levels down. We go from the browser and then we go all the levels down until we're on bit level, right? The bit level is really, really cool on Solana. They have something called compact arrays, which is designed to save 1 byte in each transaction, which, makes things faster and more scalable, right? So they have paid such an attention to detail until all levels down, until all the hardware level. You can really tell that Anatoly was working in distributed systems in Qualcomm for a long time. He was saving each and every byte or even each and every bit. But we are using that and injecting bits in that message format that will make it possible to not only access the Solana accounts, which is the fast storage, but it's not scalable, and also access the Xandeum accounts, which are called the eggs accounts. Egg stands for external global group storage. And with these eggs accounts, you can access the extended transaction that access the global storage chain. It's being provided by storage provider nodes. Hundreds of thousands of storage provider nodes all over the world will be deployed by people like you from the community to make it happen. If that sounds like an exciting project to you, please, again, give me that like button. Subscribe to my channel so that you won't miss any of the update videos that are coming out all the time. All right. But for now, thanks for watching and catch you guys later. Bye.